Among other classes, there are two specific courses I teach for the FAA Academy. The first course is a Continuous Airworthiness Maintenance Program course, the CAMP. The second course is about one of its elements, the Continuing Analysis and Surveillance System, the CAS. The CAMP program explains how an air operator tracks, schedules, controls, trains, and performs aircraft maintenance and inspections on its aircraft. Each CAMP program encompasses 10 elements found in Title 14, Code of Federal Regulations, Part 121, Subpart L as in Lima, and Part 135, Subpart J as in Juliet. Now, these 10 elements are airworthiness responsibility, accomplishment and approval of maintenance, maintenance manuals, maintenance organization, contract maintenance, maintenance scheduling, maintenance record-keeping systems, personnel training, required inspection items, also known as RII. And number 10 is CAS, as previously mentioned. Now, CAS is the Continuous Analysis Surveillance System. CAS is a regulatory requirement adopted when the 1964 Federal Aviation Regulations were written. This regulation requires air carriers to establish and maintain a system for the continuing analysis and surveillance of the performance and effectiveness of an air operator's inspection, maintenance, preventive maintenance, and alterations programs for its aircraft. Why am I telling you this? Well, the cargo airline, United Parcel Service, UPS, has a CAMP program, and as a result, a CAS regulatory element. In these two facts exists the evidence leading to the root cause for the UPS 2976 accident and how to prevent such circumstances from happening again. We will look at where the UPS 2976 accident investigation left off in November. We'll look at recent update on January 14th, and we will examine where the UPS 2976 accident investigation should be right now. So buckle up, there's lots to cover. I'm Stephen Carbone, and this is By Reason of Air Safety. Since November 4th, 2025, the aviation industry has been fed bits and pieces of a terrific accident, UPS Flight 2976. To those of us tracking this accident, there doesn't appear to be much progress. The last word investigatory agencies delivered for the accident was the NTSB preliminary report published on November 20th, 2025. The report provided nothing to answer questions industry professionals had. On page 10, the report noted the accident aircraft, registration number November 259, Uniform Papa, had a total of 92,992 flight hours and 21,043 flight cycles. Information in the preliminary report was vague about the maintenance program requirements for the accident aircraft, and it's here where the investigatory focus of the accident investigation went way off track. UPS, in the first days of the investigation, grounded its MD-11 fleet. This was a sound idea since the MD-11 had become highly suspect. The FAA published FAA Emergency Airworthiness Directive, also known as an AD, 2025-23-51. And this grounded the MD-11. FedEx, another operator of the MD-11, in response immediately grounded its MD-11 fleet. Then FAA Engineering in Seattle did something puzzling. The FAA's Air 520, the Continued Operations Safety Branch, published another emergency AD, 2025-23-53. This emergency AD superseded the previous emergency AD 23-51. It not only grounded the MD-11 fleet, but was expanded to also ground the DC-10 fleet. It wasn't the action that defied logic, it was the reasoning. It's on the preliminary reports pages 10 and 11 that Air 520 took a direction that made no sense. The investigation became muddled with unclear theory at the same time ignoring important facts. Why then did the FAA's Air 520 division choose to ground the DC-10? The answer lies in Emergency AD 2025-2353's overreaction, because it wasn't logical. According to the new Emergency AD, quote, the FAA subsequently issued Emergency AD 2025-23-53 on November 14, 2025, which superseded Emergency AD 2025-23-51 and included both MD-11 and DC-10 series airplanes, the latter, meaning the DC-10, based on their similar design to the MD-11. Remember the term similar design. The MD-11's similar design to the DC-10? What design did the FAA refer to? To be clear, Air 520 grounded the DC-10 aircraft for the sole reason, it appeared, that it had a similar design. In other words, the DC-10 looked like the MD-11. The MD-11 and DC-10 did share common system designs, such as 3 engines, but not identical. Similar pneumatic and hydraulic systems, but not identical. The landing gear configurations, flight controls, and air conditioning systems, again, are similar, but not identical, because the MD-11 is a digital version of the analog DC-10. The MD-11 has fly-by-wire, 2-man cockpit, to the DC-10's 3-man cockpit. The DC-10 also utilized cable-driven flight controls, as well as cable-driven engine controls. Yet this raises a good point, one that perhaps Air 520 was hopefully referring to, that the MD-11, the DC-10, and all subsequent models are all listed under present Type Certificate Data Sheet number Alpha 22 Whiskey Echo, Revision 13. This TCDS, Type Certificate Data Sheet, refers to the airframe. The present Type Certificate holder is the Boeing Company, who secured it when Boeing merged with the McDonnell Douglas Company on January 1st, 2010. Now, from a distance, the DC-10 and MD-11 look similar, but visually up close, the MD-11 has winglets, a belled number 2 engine inlet, a smaller horizontal stabilizer, and a longer fuselage. And despite any family resemblance between the DC-10 and MD-11, there are no similarities that have anything to do with engine mounting, which is in question in the UPS 2976 accident. So we must return to the reason Air 520 gave for updating the emergency AD. An NTSB's preliminary report stated that Air 520 grounded the DC-10 because of an accident that occurred 46 years earlier in 1979 with a DC-10-10, an accident that occurred for completely different reasons than UPS 2976. Now, to be clear, the preliminary report states, according to FAA's Air 520 management, the DC-10 should be grounded for the sole reason it has a similar design to the MD-11. The NTSB preliminary report confirms that on pages 10 and 11, the FAA, in agreement with the NTSB and presumably Boeing, ordered the DC-10 to be grounded for looking like the MD-11. The emergency AD further justified its DC-10 grounding decision by stating the FAA is issuing this emergency AD because the agency has determined the unsafe condition described previously is likely to exist or develop in other products of the same type design. This means Douglas and McDonnell Douglas wide-body aircraft. However, what similarities between the MD-11 and DC-10 did Air 520 refer to in its emergency AD? It's not clear. As previously mentioned, many systems configurations are shared between the DC-10 and MD-11, similar, but not identical. The problem is that no particular system, such as the hydraulic or pneumatic systems, were called out in the emergency AD. So the preliminary report refers to the American Airlines Flight 191 accident as a similar event. That the Air 520 division determined the events leading up to American 191 were parallel to the UPS 2976 accident. So Air 520 went from similar design to similar events. And none of this was making sense. According to page 11 of the preliminary report, American Airlines Flight 191 crashed in Chicago on May 25, 1979. NTSB report AAR 7917 from 1979 stated the accident aircraft's number one engine separated from the wing was resulted from damage by improper maintenance procedures, which led to failure of the pylon structure. To clarify, the cause of the American 191 accident was Americans' unauthorized use of unapproved maintenance practices by American Airlines maintenance crews when they had earlier changed out the accident aircraft's engine. It's clear NTSB report AAR-7917 explained the cause of the American 191 accident was not design. Why the preliminary report tied UPS 2976 to American 191 on the basis of design is unclear. But the FAA's Air 520 did not deny what the preliminary report said, nor did they ask the NTSB to edit the preliminary report. Therefore, the FAA and the NTSB must be in agreement on this point. And that is important. The only confirmed similarity between the MD-11 and the DC-10 is they were both produced by Douglas and later McDonnell Douglas Aircraft Corporation. They were both wide-body airliners with 3 engines, 2 wing-mounted and 1 engine mounted on the tail. The DC-10 was originally manufactured in 1971, the MD-11 in the late 1980s. Another similarity the DC-10 and MD-11 do not share is the engines that power them, specifically the General Electric engines. American 191 aircraft was a DC-10-10 with GE CF6-6D engines, D as in Delta. The MD-11 in the UPS 2976 accident had the GE CF6-80C2 engine. The TCDSs for the engines are listed under the General Electric Company. The TCDS for the CF6-6D engine is under Echo 23 Echo Alpha for American 191's engine, while the TCDS for the CF6-80C2 engine is different. It is under Echo 13 November Echo for UPS's 2976's engines. The UPS Flight 2976 MD-11, when its number one CF6-80C2 engine departed the wing, it had absolutely nothing to do with design and everything to do with lifetime progressive maintenance. Why? For 2 reasons. For one, the MD-11 CF6-80C2 engine and the DC-10 CF6-6D engine have different engine mounts and pylons. So even if the 6D was properly maintained as it wasn't by the American Airlines maintenance crew, they were still different pylons and mounts. And 2, the CF6-6D, its mounts and pylons were designed almost 50 years ago. The ADC-2, its mounts and pylons were designed over 30 years ago. According to the NTSB preliminary report, the MD-11's number one engine pylon was on a 72-month inspection schedule, that's 6 years, which means the number one engine pylon had received at least 4 to 5 detailed visual inspections and 5 to 6 lubrication/visual inspections in the aircraft's lifetime. Any pylon and mount design concerns were addressed over 2 decades ago with the MD-11's initial detailed visual inspection. Similar design was disproved decades ago. Now, the CF6-6D engine is 188 inches long. It's 108.4 inches wide. It weighs 7,505 pounds and produces 40,000 pounds of thrust. The CF6-80C2 engine is 168.26 inches long. It's 105.1 inches wide. It weighs 9,845 pounds and produces 60,240 pounds of thrust. These differences in length, weight, and thrust capabilities dictate the two engines have different designs for pylons and engine mounts. They are not similar. The DC-10 engine mounts and pylon from the American Airlines Flight 191 accident were designed to carry the weight, withstand the thrust rating, account for the length and diameter of the CF6-6D engine. While the MD-11 engine mounts and pylon from the UPS Flight 2976 accident were designed to carry the weight, withstand the thrust rating, account for the length and diameter of the CF6-80C2 engine. Why is this important? Because critical accident information about the UPS 2976 accident was overlooked by Air 520 when publishing both emergency ADs. Namely, the UPS 2976 engine that departed the aircraft was a wing engine. This is important for 3 reasons. First, the similar design theory is irrelevant and should never have been a consideration of any emergency AD. The MD-11 is the only airliner with the CF6-80C2 that has a tail engine. The MD-11's tail engine had nothing to do with the number one engine departure, nor did any of the aircraft's other systems. This was never called out in either emergency AD about any of the systems being a part of it. Second, the MD-11 is not the only airliner that uses the CF6-80C2 engine, and thus similarly designed pylon attachments for the engine to the MD-11. The pylon failure had nothing to do with Douglas McDonnell Douglas product designs. Third, since November 8, 2025, the NTSB and the FAA have been pursuing false positives. They grounded the DC-10 because of its similar design. Wing engine airliners that use the CF6-80C2, however, are the Airbus A300-600, the Airbus A310-200, the Boeing 767-200 series, 300 extended range, freighter, and the 400 extended range series, and the Boeing 747-200, 300, and 400 series. When the Air 520 limited their focus on similar designs of the MD-11 and DC-10, they ignored the larger picture. For one, engines and mountings of the DC-10 differ considerably from the MD-11. The similar design of the MD-11 and DC-10, when broken down to basics, only amount to they both have a tail engine, and again, the tail engine had nothing to do with what happened to UPS 2976. This became the obsession of the UPS 2976 accident investigation and Air 520's escalation of the emergency AD and the second emergency AD. The Air 520 division focused on irrelevant similar designs of Douglas McDonnell Douglas products. Air 520 ignored the CF6-80C2 pylon specifically, which means they missed important opportunities to, one, to capture stresses on all wing-mounted engines such as the B747, the A300, the B767, even the B777, the B787, and yes, even the DC-10. Another opportunity was to examine, and this is critical, all wing-mounted engine pylon inspections. 3. To determine what airlines have airliners with wing-mounted engines and have had inspections done on their CF6 ADC2 or any wing-mounted pylons, whether it's Pratt & Whitney, Rolls-Royce, or General Electric. Inspections accomplished by outside vendors, and if so, by who? That's important. In keeping with bullet 3 is number 4. How are inspections and maintenance performed on all wing-mounted engines by outside vendors? It's important to note that during the entire Thanksgiving and Christmas travel seasons, the NTSB and FAA's Air 520 division ignored inspection of other airliners using the GE CF6 ADC2 engines, whether passenger or cargo. Precious time between the accident to today was spent pursuing a similar design when design had nothing to do with what happened. On the preliminary reports, page 10, the left pylon on the accident aircraft received a 72-month detailed visual inspection on October 21st, 2021. This was the engine that flew over the top of the wing. It also received a 24-month or 4,800 flight hour pylon lubrication of the pylon thrust links and pylon spherical bearings. We will talk about those later, and that was last accomplished on October 25th, 2025. On January 14th, 2026, the NTSB released an update on the UPS 2976 accident. A Boeing service letter, MD-11, Service SL 54104-Alpha, dating to February 7th, 2011, was published, and immediately the internet and social media were alive with accusations against Boeing. According to the NTSB update, the service letter pointed to the MD-11 pylon aft mount bulkhead spherical bearing assembly. There it is, that's what I was pointing to. A spherical bearing race failure on part number Sierra 00399-1 had been previously reported in 2011 4 different times on 3 different airplanes. I'm going to repeat that, the second part of that, on 3 different airplanes. The service letter stated Boeing MD-11 airplanes inspection of the spherical bearing assembly would be included in the general visual inspection, and detailed visual inspection of the pylon aft mount normally at a repetitive 60-month interval. So what to take from this service letter? It reported a call for a general visual inspection by maintenance and inspection. Was this a possible design failure 20 years into the MD-11's lifetime? The service letter didn't say design or engineering was not addressed, investigated, or was ignored by Boeing. On page 5, the NTSB update did say the Boeing MD-11 maintenance manual was updated to include inspection of the spherical bearing race for evidence of migration, specifically by checking that the spherical bearing is not protruding forward or aft beyond the surfaces of the pylon aft mount lugs. The service letter went on to discuss a new part number that could be used. That was all very speculative. That was all every speculator and so-called expert needed to hear. Boeing didn't jump fast enough in the following 14 years to create a fix, even though they did. What everyone chose to ignore was the next paragraph where the NTSB update mentioned, investigators are reviewing UPS's incorporation of the contents of the service letter into its Boeing MD-11 maintenance planning documents, and maintenance manuals is ongoing. Clearly, this was not reference to design. This was a maintenance failure. As I mentioned earlier with a camp, The inspection program falls under the operator's camp. So what are the takeaways? Well, first, even the NTSB realized UPS or any MD-11 carrier had the option to replace the part with a modified part, as found on page 5 of the service letter. This was disingenuous of the NTSB to place focus on Boeing and leading gullible people to believe it didn't act as appropriately to replace the Sierra 003991-1 part with the Sierra 00399-523 part. However, they did point out further back in the report that the air carriers themselves own the blame if they did not replace with a modified part or didn't address it in their camp. And second, and most importantly, the service letter is an MD-11 service letter. It is addressing operators of only the MD-11 and maintenance to be done on only MD-11s. Now, while it called for inspections for the MD-11, the service letter did not state that the 3 airplanes where the 4 previous reported events occurred were limited to MD-11s. They just said they were airplanes. It is understood the pylon is an airframe manufacturer's design, in this case McDonnell Douglas. However, the engine in question is the CF6-80C2. That's an important consideration that people are ignoring. How did then Boeing and Airbus design their pylons for this engine, for the 767, for the Airbus A300, for the A310, or the 747? Is the NTSB assuming that Boeing and Airbus didn't have similar pylon designs using comparable spherical bearings? This needs attention. The NTSB in all past accident reports rarely addresses other same model aircraft and, in this case, engines. The attention is always on the accident aircraft, not the industry or comparable fleets. In this accident report, the NTSB is only answering the question, why did UPS 2976 crash? Important questions for investigators to track. Has the maintenance and inspections performed on UPS 2976's pylons been researched to see who performed it last? Were those who conducted these inspections employees of UPS, or did they belong to a contract maintenance organization? If they worked for a contract maintenance organization, were they located in the United States, or were they internationally located? And if so, where? When I worked for the NTSB as a major accident investigator, the aviation investigatory divisions were focused on engineering. Before I got there and after I left, those who investigated aircraft maintenance, structures, power plants, and systems were and are engineers. Now, this may seem like a trivial point, but I assure you it is not. Air 520 itself is an engineering division for the FAA. This division focuses on engineering, not aircraft maintenance or inspection, also known as M&I. So if I use the term M&I, I'm talking about maintenance and inspection. But it isn't their fault. Engineers are conditioned by reliability-centered maintenance, which first basic principle is one can't maintain an airplane to achieve reliability. Instead, reliability must be designed into the airplane from the beginning. This concept sprang from the aviation industry's conscious decision to evolve away from the pre-1964 maintenance assumptions, such as more maintenance is better. Now, engineers contribute to aircraft maintenance programs to account for the aircraft's normal wear and tear, lifespan, proposed use, such as where and how the aircraft will be used, structural limits, and the manufacturer's technical data. Unfortunately, engineers focused on engineering cannot relate to maintenance and inspection issues because engineers aren't experienced in maintenance and inspection issues. Engineers aren't trained in maintenance and inspection. And therefore, engineers don't understand maintenance and inspection. Engineers design to standards an engineer sees and knows. However, engineers rarely venture beyond the limits of their world. That is, engineers seldom see an aircraft once it leaves the assembly line. And that is why engineers investigating post-manufactured aircraft accidents doesn't make sense. Engineers may never see the airplane they designed, ever. After rollout, airliners are operated in the airline world, populated by aircraft technicians and inspectors. This is the M&I world of phase checks, component replacements, ramp strikes, de-icing, engine changes, pushbacks, and walkarounds are where opportunities to correct safety problems exist. Engineers don't see these opportunities and wouldn't recognize them if they did. This is why the UPS 2976 investigation has become bogged down. NTSB engineers who are investigating are dealing with causes they cannot comprehend, such as camp programs and how they are run. For example, the MD-11 pylon failure was not a design failure. It's a camp failure. In the introduction, I showed a group of regulations, Title 14 CFR, Part 121, Subpart L as in Lima. That was important because UPS is a Part 121 air carrier. Why was this important to point out? Well, the 10 elements of an operator's continuous airworthiness maintenance program, its CAMP, are supposed to be monitored and corrected by the 10th CAMP element, what we call the Continuing Analysis and Surveillance System, or the CAS. That the CAS tracks safety problems with itself and the other 9 CAMP elements. Most importantly, the CAS receives its data from maintenance and inspection personnel, not engineers. Because the UPS MD-11 problems have gone from design error to progressive maintenance and inspection error, the UPS 2976 accidents root causes are going to be found with one or more UPS CAMP element failures, including the UPS CAMP's CAS program, which should have identified the causes before the accident could occur. Trained maintenance and inspection professionals conduct CAS audits because they have the experience, the knowledge, and qualifications to identify problems in the air operator's camp. Since audits and quality control depend on those who are experienced, engineers must not investigate what they lack the training, the analyticals, the knowledge, and experience to understand. To put it clearly, the root cause findings of UPS 2976 will not be reactive, as is all NTSB accident investigations. Why? Because the UPS CAS program existed to be proactive. The CAS wasn't designed to fail, thus it wasn't a reactionary failure. UPS's CAS failed because it wasn't used right. The aviation industry is going to find many problems that were not only preventable, but hiding in plain sight. Problems with training, oversight, regulatory abuses, contract maintenance, and so on. The aviation industry must face the facts that the COVID shutdowns, restricting regulators from traveling internationally to do surveillance, and the extension of required oversight over a span of years instead of a year or two have created devastating problems that the industry hasn't anticipated and never planned for. UPS 2976 is not the first post-COVID tragedy, and it's believed it won't be the last. Things will continue to get interesting if the aviation industry doesn't rethink how the last 6 years have harmed us. Furthermore, the NTSB does not understand maintenance programs and are outside their depth in investigations like UPS 2976. I don't know how to be more clear. The work back to aviation safety is not going to be easy. Until next time, I am Stephen Carbone reminding you to tab. Think safe, act safe, be safe. God bless.